Okay, in this lesson, we're going to look at transition matrices. So a transition matrix is we use it to like predict what will happen in the future. Sort of like they take the stats and they've seen what's happened previously with things, and then they create this transition so that we could assume or we can predict what might happen in the future. So this example that we're going to work through at the start is that they've looked at all the stats and whether it would rain on the day or whether it'll be dry on the day. So as I said, a transition matrix is used to predict what will happen in the future, and they've based it on what they've gathered data previously. So when they say the transition matrices shows you from state to state. So say for this example here, we've got a transition matrix, and we're talking about whether it was raining on one day and then the state of the day the next day. So is the day raining or is it dry? So that's what they're talking about. So we set up these transition matrices, and you'll notice that they're square. So this one's a 2 by 2. And often you get a transition network diagram to begin with. And so you can see, if we follow this through, we can see the chances of, if it rained today, so I'm over at rain, if the chances that it'll be dry tomorrow is 0.5. So you got a 50% chance. Now, if you were on a dry state, so meaning if the day you're on was dry, you have, so you would be here, you've got a 50% chance that it's going to be dry the next day. And so this is explaining the transition matrix. So we can always, when we go to set them up, if we're given the diagram, obviously we will have a square matrix, and then we often, because we're saying from state to state, we normally say that, say this is today or the first state, the state, and then we're going to say tomorrow, what tomorrow will be, and that's you moving to the next they call it state, but it could be different. Like, so we might be talking from, if we're talking today, the state is a day, but it could be, depends what the data is talking about, could be, month or whatever they're talking about. So you can see they had, they set it up, and if they've got raining, if you were raining today, or whether it was dry on the day you're on, okay, and then you go across whether it would be raining or dry tomorrow. So this from rain to rain, so rain to rain, from rain to dry, I beg your pardon, is 0.5. And if you were on rain today and it was going to rain the next day, it's a 0.7. So 0.7, there's that one. So if I do it was dry today and dry tomorrow, so dry today, dry tomorrow is 0.5, and dry today and maybe rain tomorrow was 0.3. So the other thing we need to remember about transition matrices is if you add up the columns, they should add to 1. So if you see, if we add those two up like that, you can see they both add up to 1. So a transition matrix should add up to 1. Okay, so we get this transition matrix to begin with. We're either given it or we have to set it up. And then what we have to do is then we'll say, we'll call like the initial state. So the initial state is sort of what happened on the first day. So what happened first? What happened first is your initial equals your initial state. So in this this scenario here, what they said is on the first day they decided to look at, start predicting. They said it actually rained. And so we've got the chance of it raining is 1 because it actually rained, and the chance of it dry is 0. Okay, so then what we do is we can use this transition to predict what our chances would be on the next day. So say that was this is what happened day 1, and we know that was the case. So if I go to find day 2, what we're going to do is we're going to use this transition matrix, that square one, and we times it by the scenario of the initial state and what happens. So we're going to see day 2. So we often call it state. So they called that state 1. And so then we're going to say state 2 was found by doing the transition times state 1, what happened the day before. So you do that and then you'll get this. So let's do that on the calculator and have a look. So I've typed this in the purple into the calculator, and then what we end up over here is this 2 by 1. So remember, this is the chance of rain, and this is the chance of dry. So for day 2, the chance that it'll rain is 0.7, and the chance that it'll be dry is 0.3. And so then we could say, you know, and you can just keep on going. So if you wanted to get the next day, you use the transition by times the day before. Okay, so we'll get more into that in a minute. Let's keep going with our examples. Okay, so setting up a transition, you got to say that you say from this to this. So we're going to say, so from and to. So we're going to set them up. So we want to set it up like this all the time so that the columns will add up to 1. Otherwise, it won't work. Okay, so they'll often give a scenario. So I'm going to go through this scenario here, and we're going to set up a diagram for you so you can see a transition network diagram. So transition network diagram for this scenario. So it says that we've got trucks in a company delivering between 2 locations, A and B. So you have location A, you've got location B. And it says 70% of the trucks, so I'm doing this data here, 70% of the trucks that start at A will park at A at night. So going from A back to A is 70%. Now, we're talking about percentages, and I just told you before the transitions need to add up to 1. So our percentages change to a decimal. So 70% is 0.7 as a decimal. So we're going to leave it like that. And then it said the other one was 60% of trucks that start at B will be at B at the night. So that's B back to B is 60%. So I'm going to change it to 0.6. Okay, so if we're setting up our transition, I'm just going to move it over here. That one's a bit blurry. So we're saying you start here and they end here, and we've got A and we've got B, A and got B. So we saw the first one. If you go back to A is 0.7, and then B back to B is 0.6. Sometimes it's easy to calculate. It's easy to calculate the ones going back to itself. So which is what they told us, the B back to B and A back to B. Now, because you know these have to add up to 1, you can actually calculate the rest of the percentage. So this would have to be 0.4 to add up to 1, and this one would have to be 0.3 to add up to 1. So therefore, I could finish my diagram. So those that start at A but finish at B, that's 30%. So 0.3, or we could say 30%, depends what your diagram's showing. And then those that start at B but end at A is 0.4. So start at B and end at A is 0.4. So there I've set up a transition diagram, and here is how we get the answer. So we just got to remember that they have to add up to 1. Okay, so let's have a look at this other example. So we've been given a transition diagram, and we want to create a transition matrix. So we've got to put our 2 states, or 2 things that are happening. So we've got A and B. So A and B. So this is where you're going to start, and this is where you're going to end. So A and B. Now, so just like in simultaneous equations, we want this order to, how it goes AB, we want that order to match down that way as well. So if we follow the diagram. So we got A back, well, this is the same scenario, but A back to A. So they're often easier to put in. So A to A is 0.7. And go look for the B to B, because they are easier to put it. You know, you're going from B back to B, so it must be this spot. And we'll go, so that's 0.6. So then if we were filling in the other one, we could know that the columns have to add up to 1, or we can hopefully, our diagram tells us that anyway. So if we start at A and we go to B, following that arrow there, you get, so you start at A and you're going to B, you get 0.3. And that's good, because that means that our columns add up to 1, which is what we want. And if you do the other one, you start at B, go to A. So start at B, go to A is 0.4, and that's what we want, because they add up to 1. Okay, so then we'd use this transition diagram to predict where our trucks, the percentage of our trucks are at which warehouse they're at. Are they at A or at the B? Okay, so here's a bigger one. So we've got a transition network diagram here, and it says the diagram gives the weekly rental rates of rental cars at 3 locations, Albury, Wodonga and Benalla. Construct a transition matrix that describes the week-by-week return rates to each of these locations. Convert the percentages to proportions. So that just means, so for example, we don't put percentages into our transition matrix. So say 70% becomes 0.7. All right, so let's have a look. When we've got, now we know the transition has to be a square matrix. So we would have, so it's going to be a square, and we're going to have, because we have 3 locations, say Albury, Benalla and Wodonga, we're going to have those down there. And and we're going to say that if we start here and we end here, and we'll follow the percentages. So as I said, it's always easier to do the ones back to itself first. So I'm going to do this one. A back to A is 70%. So A to A, that's this spot here. A to A is 70%. Then I'm going to do the B to B. So B back to B is 77. So B back to B is this spot. So I'm going to put 0.77. And then the last one, C back to C, Wodonga back to Wodonga is 80%, so 0.80. So I've done those ones. They're often the easiest ways to do. Now let me look at some of the others. So I'm going to start at A, and if I follow this arrow here, A, starting at A, but going to W, that's here, that is that's 10%, so I'm going to change it to 0.10. Okay, and then if I just want to finish off, I'm going to do that. Start at A and go to B. That's here. Start at A and go to B. That will be in here, and that's telling me that one is 20%. So then it's that one in here. So 0.20. Now we can see that we have done that correct, because that adds up to 1. So that's all good. So let's go finish it off. Let's look at B. And if I go from B to W, so from B to W, I've got, it says 11%. So I would write that as 0.11. If I go from B to A, so B to A, that would be here. B to A, that's 12%, so I put 1, 2. And then let's fill in the rest. If we were starting at, I'm just going to delete all this to make it a bit easier. So I'm going to do the W one now. If I'm starting at, if I start at W and I want to go to B, so start at W, go to B, that's 15%, so that'd be 0.15. And start at W and go to A, that's along there, that's 5%. So let's just, now, whoops. Now, don't get caught. Remember, 5% would be 0.05. So just be careful, because I nearly did it there. So 0.5%, you've got to have the 0.05. Now, if we add these up, we should get 1, which we do. You add those up, and then if you add these proportions up, you also get 1. So you know you've done it correctly if they add up to 1. Okay, so here's another example. A factory has a large number of machines. Machines can be in one of two states, operating or broken. So if you're talking about your states, you're only going to have a 2 by 2 because you've got your two states, operating, broken, operating, broken. Okay, so they've given you on a given day. So they want us to construct a transition matrix, but I'm going to, just so we can practice, I'm going to do a transition diagram first with our knowledge, and then we do it. So we've got operating and we've got broken, and I'll go through their first things. So they said 85% of machines that are operating stay operating. So operating back to operating is 85%. And then 15% of the machines that are operating break down. So if we do this one here, 15 from operating go to broken. So 15%. And then we've got 5, if we could do the next one, we've got 5% of machines that are broken are repaired and start operating. So broken to operating is 5%. And the last one, when they say 95% that are broken remain broken, so that's 95%. So that would be if you had to draw a diagram up from it. But they want a transition matrix, so we know it's a square. We know we have operating, broken, operating, broken. Now, just as long as it matches you that way, if you'd put the broken first, it doesn't matter, you still get all the same answers. You just got to be careful that you're matching it. All right, so operating to operating, that was 85%. So remember, if we start, we end here. So if you started operating, but it was by broken, it was 0.15. And broken to broken was 95. And broken to operating was 5%, so 0.05. So there you can see we can set it up and they add up to 1. So just here where they say use the start of the day as the rows and the end of the the rows to describe, the columns to describe the start of the day. That is what I meant, where we start here and end there. We always do that. So that was their way of saying that, okay? But we always will follow this way for a transition diagram. Okay, so here we've got the transition matrix, and they've given us, and it's describing these the rental cars and how many cars they have at each of the locations. Now this is from week to week. So when we're saying week to week, so at the end of the first week, 80% of the cars at Albury returned back to Albury. That's what that's Wodonga, but that's what that means, okay? So we're talking about how much percentage of the cars. So it says here, use a transition matrix diagram to answer the following questions. So what percentage of cars rented in Wodonga each week are predicted to be returned to? So you're starting at Wodonga here, and you want to go to Wodonga to Albury. So predicted to turn back to Albury is 5%. From Wodonga to Benalla is 15%. And Wodonga back to Wodonga is 80%. Okay, now they've said 200 cars were rented at Albury this week. How many of these cars are expected to be returned to? Okay, so returned to Albury. The first one's at Albury. So we have 200 cars at Albury, and so we know Albury back to Albury is 80%. So we want 80% of 200, which equals, you can just do 0.8 times 200 if you like, which equals 160. So you know 160. And then they said of the 200 at Albury, how many ended up at Benalla? So you think this next part is Albury to Benalla, which was 20%. Sorry. So you want 20% of the 200. So which, if you want to change it to decimal, it'd be like that, which equals 40. Okay, so that'd be 40. And then the last one is they want to know what Albury went to Wodonga. So Albury to Wodonga is 10%. So 10% of 200 equals 20. So you know 20. So and now it says, what percentage of cars rented in Benalla each week are not expected to return to Benalla? So if I do this one here, sorry, I'm going to do C. So we want Benalla now not to be returned. That would be Benalla to Albury and Benalla to Wodonga. So if we look at Benalla to Albury, that's 12%, and Benalla to Wodonga is 11%. So we just would add them. So 12% plus 11%. So we're going to say 23% of the cars of Benalla, of the Benalla cars, don't return to Benalla. Okay. And then this last question here, 160 cars are rented in Albury this week. How many of these cars are expected to be returned to either Benalla or Wodonga? So we want Albury, and we want them to go to Benalla or Wodonga. So if you look at those percentages, Albury to Benalla is 0.2, and this is 0.1. So it's pretty much 0.3, because you add them together, times 160, which equals 48 cars. Either going to go to either Benalla or Wodonga. Okay, so we can see we can always get the next week or next state by using the transition and timesing it by, whatever numbers they said. But what happens is we're going to go ahead, and what if they said in 5 weeks' time? I'm going to have to keep on going. Like I get what happens after 1 week and then use the transition matrix again. So it's going to get a little bit annoying. So we are going to there's a system that we can find another state using the transition and also the initial state. So the initial state is represents the starting conditions. So what happened? So when we're talking about the cars at those 3 rental places, it would have been the number of cars at each of those. Okay, so we call this initial state, and we're going to call it SO, the first one, the what's happening in the beginning. And the way we can find, we can write this in recurrence relations. So we've used these recurrence relations before, and we know when we see that we're talking about the states, if we see this writing here, the n plus next one, it's just how you get the next term, or then how you get the next state. And so how we get the next state is, so we'll be talking how we get the next state is we get the transition and we times it by the state before. So, and this one means using the state before. So what that means is, so say I had to, say for an example, I wanted to find what happened in state 4. So that would be, say, week 4. What I would have done is I would have done the transition times the one before, which is state 3, what happened in state 3. So that's what this rule is saying. You can get the next one by timesing it with the transition. So another example, if we just really want to get the very next state, we do the transition times the one before, which would have been SO, the original state matrix. But obviously, if we kept wanting to go ahead and say we're not going to keep on going, say I wanted to get state 20, I don't want to have to keep going over and over again. So sometimes that's when we're going to use this rule here. So it says when you want any state, what you can do is you can do the transition to the power of, because I want state 20, I'll do the power of 20 as long as you times it by the original scenario, so SO, so what initially happened. So, and a good way to know is whether you've got the right, is that this number and that number there should add up. So if you do 20 plus 0, it should add up to what you've got, what you want to find, which is 20. So if you look up here, it works for up here, because really when you just have the transition by itself, it's like the power of 1. So you can see 1 plus 3 does give 4. So that can work as well if you need to calculate what you need to do. All right, let's give it a go with this example down here. So the factory has a large number of machines. The machines can be in one of two states. This is the operating or the broken. And at the start, the 80 machines are operating and 20 are broken. Okay, so we're looking at here. So you can see that is giving you the initial state matrix when they tell you that. So that means they're giving you actually what happened, and we're going to say operating and broken because that's the way it was set up here. So we're saying 80 were operating and 20 were broken. That's the initial state. So, and this is the transition that tells you day by day. So it says determine the number of operating and broken machines after day 1. So if we want day 1, that's essentially state 1. And if they want day 3, that's state 3. Okay, so I'm down here, I'm going to calculate. If I want to find S1, knowing the rule, I can do the transition times the one before will give me the next one. So I could do transition times SO. So into the calculator, I'm going to type in this transition matrix, and then I'm going to times it by the one before, which was SO to begin with, so which is 80 times 20. So I do that on the calculator and I'll get an answer. So out on the calculator, when you do this, you get 69 and 31. So what that means is this was operating, this is broken. On day one, there is 69 operating machines and 31 broken machines. Okay, now to go to do the next one where they wanted state 3, now I could just keep on going and using this is actually now, this is state 1 there. So you could find state 2 by timesing this one by the transition, but I'm not going to do that. I can't be bothered. I'm going to do this power trick thing, we call it. And then we're going to do, so I'm going to do the transition. And I've been given SO, so I'm going to use SO. Now I'm going to say to the power of 3, because then I know those two numbers add up to 3, which is what I want. So into the calculator, I'm going to type up this matrix again, and I'm going to put it to the power of 3 and times it by the original initial state, and then I'll get my answer there. Okay, so with my answer, I've got decimals, so I'm going to round it to 53 and 47. What we want to make sure, we're not losing any machines. So if you look, in total, we had 100 machines. Okay, so these numbers should add up to 100. So careful with your rounding, and make sure that they're still on 100, which it is. So on day 3, we can say that on day 3, there were 53 operating machines and there were 47 broken machines. Okay, so this is just explaining that nth term formula. So what was the nth term is when we said Sn, to find any state, we're going to do the transition to the power of n times the initial beginning. Okay, so that's what is written here. So say for our example we just did, if you remember, when we wanted to find state 3, we did the transition to the power of 3 times SO times the original. Okay, one last more example. The factory has a large number of machines. The machines are in either operating or broken, so we're still using this same thing. And it said 80 machines are operating, so you know that's operating and that's broken, and then therefore your transition must be following that pattern too. And it says determine the number of machines broken after 10 days. So that means state 10 is the question. So I'm going to use that nth term formula where we said we can find any state by raising it to the power of that state times the initial what's beginning. So in this example, I'm going to pop in that transition again, and this time I'm going to do it to the power of 10 and times the SO, which is 80 and 20. So you just pop that into your calculator and we get, okay, so you get 30.9 and you get 69.1. But as I said, like, these are machines. You're not going to have a point, a point of a machine. So we do like to round it. So I'm going to round that to 31 and that one remain at 69. And remember, because the total here, we didn't lose any machines, there's 100. So that totals 100, so that's good. So determine the number of operating and broken machines. So just because they've asked us, we need to make a statement. So we'll say operating equals 31 and broken equals 69. Okay, if we quickly go through this example, we can see that it says customers go to a grocery store, either A or B, and it says 75% of those who go purchase at A return to A. So you can see there's the 75%, and then they go on to say, but if they previously were at A, they went to B. Okay, so there you can see that. And then then they said in their blurb, they said those at B, 80% returned to B, and then obviously therefore 20%, because remember these have to add up to 1. So you've got your transition, and it says how many customers at the end of this. Now this is from month to month for their groceries. So how many customers are still purchasing from A and B at the end of 2 months if 300 customers started at A and 300 customers started at B. So here they gave you an SO. They gave you initial state. And we're going to say A and B, and they've told us there's 300 and 300. And how many are at the end of 2 months? So the question there is they really want state 2. So you would do the transition to the power of 2 times that SO, which is just here. Okay, and you can see they show this in the calculator, but they do the storing, but it's still the same. So you end up with, here it is, T2 times SO, and then we get that. So they would round this. This is A and this is B. So they're going to say 277 at A and 323 at B. Okay, and then they wanted to know what percentage of customers are purchasing their groceries at A and B at the end of 6 months if 50 of the percent started. So this is another scenario. You're using the same transition, but your SO is changing. And SO, we're just going to use a proportion. So we can say, you can use 0.5. You could have still used 50 if you like, but it doesn't matter. Well, they've changed it to a 50. So they're saying if 50 started at A, if 50% started at A, then 50%, the other 50% must have been at B. And this is where they get the SO. And they said after 6 months, so they really wanted S6. So you can see they've done to the power of 6 times SO, and then there they've found it. Okay, I'll let you go do the exercise now. And you're just going to do exercise 12C. And I wanted you to do, it's parts 1 and 2, and also section 3, but only question 1 and 2 in the part 3 part.